Hello everyone, I hope all of you are fine. Today we will discuss on transformer protection. Under this discussion, we will cover the following contents, which is introduction, different transformer faults, transformer internal faults and external faults, choices of protective schemes, protection in transformer and different protective schemes. This lecture is basically overview of transformer protection. So now starting with the introduction, basically the two major items of equipment in a power system are the generators and transformers. Chances of fault occurrence on them are very rare as compared to on lines, but the damage caused by the faults usually takes much more time and money to repair than are required to repair the damage caused by the faults on the lines. Rapid reclosing of circuit breakers is feasible on lines and it helps in saving the amount of damage, while a fault in a generator transformer always requires some attention of the supervisory staff. Fast clearing of faults, however, assists in reducing the damage clearing of faults to the equipments and also reduces the interruption in power service caused by drop in voltage and from instability. Basically, power transformers are static devices. Those are totally enclosed and usually oil immersed, and therefore chances of fault occurrence on them are very rare. But the consequences of even a rare fault may be very serious unless the transformer is quickly disconnected from the system. So we need automatic protection scheme for transformers against possible faults is essential and of utmost importance. These are the block diagram representation of different types of transformer faults. Basically, we can divide in two types. One is internal faults and second one is external fault. In internal fault, we will categorize the phase-to-phase fault, phase-to-earth fault and inter-turn fault. Basically, phase-to-phase short circuits are most frequent on leads of three-phase transformers, while the interphase short circuit, that is also known as phase-to-phase short circuits within the windings, are less frequent. Whether earth faults and inter-turn faults have the highest probability on the power transformers. Winding short circuits, also called the internal faults, generally result from failure of insulation due to temperature rise or deterioration of transformer's oil. An open circuit in one phase of a three-phase transformer may cause undesirable heating, but this condition is relatively harmless and so no relay protection is required against open circuit. So next one is transformer internal faults. Basically, these are the most common reasons for occurrence of internal fault in the transformer windings. That is, first one is breakdown of the insulating oil, second one is insulation failure of winding, overheat generated in the coils and due to failure of insulation. Due to these reasons, we will see that the occurrence of internal fault in the transformer windings. Now, transformer external faults. There are two types of regions or possibilities due to transformer external faults. That is transient surge voltage, that means arcing ground if neutral point is isolated, or switching operation of different electrical equipment. Due to this switching operation of different electrical equipments, maybe transient surge voltages occur in transformer, or this will be caused for transformer external fault. Atmospheric lightning impulse, I think all of you are aware with the lightning. So due to this atmospheric lightning impulse, there is over voltage across the transformers, and due to this over voltage, external voltage occur in the transformers. Now next one is power frequency over voltage. The reason is that we know that the EMF equation of transformer is induced EMF, that is represented by voltage V equal to 4.445 F into N. That means voltage is directly proportional to the working flux. So when the increased voltage causes proportionality increase in the working flux, this therefore causes increase in iron loss and disproportionately large increase in magnetizing current. the increased flux is diverted from the transformer core to other steel structure part of the transformer, that is core bolts, and the core bolts which normally carry little flux may be subjected to a suddenly large component of flux diverted from the saturated region of the core alongside. Under such condition, the bolt may be rapidly heat up and destroy their own insulation as well as winding insulation. That means the external voltage occur due to the sudden increase in the working flux and due to the heat up of core bolts. So this is the basic reasons to occurrence of the external faults. Now the choice of protective scheme, that means there are the several factors which depends for choosing of the protective scheme. So these are the several factors. Under this the protective scheme we will choose. The first one is type of transformer. That means the type of transformer, that means either power transformer, either distribution transformer. If we have distribution transformer, so for distribution transformer basically employed in rural area, the normal practice is to use the fuse for its protection against external faults, but for urban distribution networks where discrimination is absolutely necessary, fuses will not serve the purpose. Now if we move to the power transformer, so for power transformers the protection is to be provided usually against dangerous overloads and excessive temperature rise. Dangerous overloads may be due to external fault or due to the internal ones. External faults however are cleared by the relay system outside the transformer within the shortest possible time in order to avoid any danger to the transformer due to these faults. Hence the protection for internal faults is to be provided in such type of power transformer. So second one is size of the transformer. That means the size of the transformer is also matter for the choice of protective scheme. Which type of cooling we will use in the transformer system where used, where the power transformer is used, that is its electrical location in the network, the importance of service for which it is required. So these are the several factors where we can depend for the choice of protective scheme. So next one is protections in transformer. So we can know that there are two types of protection zone, that is the main protection and backup protection. So if we will talking about the main protection, these are immediate fault clearance protection which acts instantaneously to clear the faults in the transformer, that is differential protection and overcurrent protection. If we move to the backup protection, this protection will act as a backup to the main protection, that is if the main protection fails, corresponding backup protection will act safeguard to the device from fault. Now we will discuss one thing, that if we are in common practice to provide Buchholz relay, that protection to all 500 kVA and above transformer, while for all small size distribution transformers only high voltage fuses are used as main protective device. If we move to the larger rated and important distribution transformers, overcurrent protection along with restricted earth fault protection is applied. Differential protection should be provided in the transformers rated above 5 millivolt ampere. Now these are the different protection schemes we will learn in our syllabus. These are the most common protection schemes for transformer protection, that is Buchholz relay, percentage differential relay, harmonic restraint relay. Basically this is the protection against magnetizing inrush current, generator transformer unit protection. So next class we will discuss one by one this protection relays working. So thank you very much.